Hi students, welcome to today's class. Today we are studying about timers in 8051. Okay, so the purpose of a timer is to create a delay or time gap between the events. So this is the function of a timer. So producing a delay or time gap between some events. Okay, now if hardware delay is used, delay is created by the dedicated hardware called timer or counter. So the processor will be free to do other operations. If software delay is used, processor will be busy performing the delay operation. So what it means that there is hardware uh, delay and software delay. So in hardware delay, the delay is given by or timer or counter. So the processor will be free to do other operations. That is, the processor need not give any delay to the program. So if software delay is used, then the delay is not given by timer or counter, then the delay is given by the processor itself. So the processor is busy in doing the delay. So there are hardware delay and software delay. Hardware delay is done by timer or counter, software delay is done by the processor. Okay, 8051 has two up counters, that is T0 and T1. 8051 has two timers, that is T0 and T1. Okay, now both these timers are 16-bit registers. Okay, both these timers are 16-bit registers. Since the here we have 8051 is an 8-bit architecture. So since the timer is 16-bit, it can be used as two 8-bit registers. Okay, that is TL and TH. That is upper 8-bit register and lower 8-bit register, which means that here we are using the 8051 is a 16-bit is a 8-bit architecture. It's a 8-bit microcontroller. Since it has the timer of 16-bit, so 16-bit register. This timer has 16-bit registers. So the 16-bit can be used as two 8-bit registers, that is TL and TH. TL means lower 8-bit and TH means upper 8-bit register. Okay, so there is timer 0 and timer 1. For timer 0, there is TL0 and TH0, that is timer low byte and timer 0 higher byte. For timer 1, there are TL1 and TH1, that is timer 1 lower byte and timer 1 higher byte. So this is the figure of or the register of timer 0 and timer 1. So this is timer 0. In case of timer 0, the lower bit is called low low byte, that is TL0. The upper byte is called TH0. And here timer 1, the lower byte is called TL1 and the upper byte is called TH0. Okay, sorry, TH1. Now, these timers play the dual function of being timers and counters. Okay, so these timers can be used as timer or counter. So we are describing the timer as timer or counter. So it can be used timer and counter. As timer, they generate time delay. So timers is used to generate time delays. As a counter, they are using to used for count events. Okay, so counter is used to count the events. Okay, so we know that counting means nothing but if there are different process or 10 process, it will, the counter will be given 10, then it will decrement. So the counting process is done by counter and the time delays is given by timer. Okay, now the timer action is controlled by T-con and T-mod registers. So there are two types of registers for timers, that is T-con and T-mod register. We have already studied what is T-con register. That is T-con register in case of interrupt. This is called T-con register. In T-con register, there is 4 bits for using timers. That is for timer run 1, timer run 0, timer run control unit. Okay, then TF0 and TF1, that is timer overflow. So this is the T-con register. Now we want to study T-mod register. Once the clock pulse reach the timer, it start counting up from 000 to FFFF. Okay, so the clock pulse is used to trigger the timer or counter. So when the clock pulse reaches the timer, the timer will start counting from 000 to FFFF. Okay, once the register reaches FFFF and is said to have overflowed, the microcontroller reset the timer register to 0000 and set the TF1 TF0, that is timer overflow bit in TCON register to 1. Okay, so if the pulse reaches, or if the clock pulse reaches, the timer starts to count. Then the timer starts to count from 0000 and its counting end at FFFF. Okay, so after reaching the counting FFFF, then it's said to be overflowed. It is overflowed. So the register TCON register, there is overflow bits, that is TF0, timer overflow bits, that is TF0 and TF1. So in TCON register, the timer overflow bits become set, that is it is given 1 1. Okay, so so the microcontroller will, or the programmer will alert, or programmer will see this TCON register TF bit as 1, then the programmer will understand that an overflow occurs. Then the programmer will reset the timer or counter. Okay, then the counting process will be continued. Okay, so that is the process. This alert the programmer that the overflow has taken place. Okay, now this change in the value of TF0 and TF1 flag will occur at regular intervals of time and can be used to generate accurate time delays. Okay, so this TF0 and TF1 is responsible for reloading the timer or counter by setting the register in TCON. Okay, now we have T-mode register of 8051. It is not bit addressable special function register, only byte addressable SFR. So this is byte addressable. So we can't use bit by bit here. We only use a byte, that is, we use byte at a time. Okay. Now set usage mode of 2 timer, set low 4 bits for timer 0 and set 4 bits for timer 1. So this is the T mode register. T mode register has bits like M0, M1, C bar, T bar, gate, then it will repeat, that is M0, M1, C bar, T bar, gate. Okay, so the first 4 bits, that is lower bits, is used for enabling the timer 0, and the higher byte is used for setting and resets timer 1. So the lower 4 bits is used for setting and resetting of timer 0, and the upper 4 bits is used for setting and resetting of timer 1. Okay, that is if the timer 0 is working, then timer 1 will be 0. If timer 1 is working, this timer 0 section will be 0. Okay, then next we want to study each bits in detail. So first bit we want to study is C bar T bar. Is nothing but it is used to select counter and timer. Okay, it's a bit C bar T bar, that is clock bar timer. So it is used to select counter or timer. This is best to indicate whether the timer is used as delay generator or an even counter. Okay, so C bar T bar, when it is equal to 0, since T bar is a active low pin, it will active when it is 0. So C bar T bar equal to 0 means this will be active. That is, it works as a timer mode. Okay, so count external frequency of T1 and T0 pin input. Then C bar T bar equal to 1, which means that this works as counter mode. Okay, so this is the pin C bar T bar in both timer 0 and timer 1. C bar T bar in timer 0 means that timer 0 work as counter or timer. Here C bar T bar means timer 1 work as counter or timer. Okay, then next bit is gate. So gate is responsible for on timer 0 and timer 1. So gate is responsible for setting the timer 0 and setting, this gate is responsible for setting the timer 0, and this gate is responsible for setting the timer 1. Okay, every timer has a mean starting and stopping through software, through hardware method. Okay, we already discussed that timer can be work as software or hardware method. When gate equal to 0, which means the timer is used for software only. The gate is equal to 1, which means the timer is used hardware only. Okay, so gate is equal to 0 means this timer is not used. then the software timer is using. If gate equal to 1 means this timer or counter is using. Okay. Then okay, if gate is equal to 0, software is used for time control. So it is the responsible for the processor to giving timer delays and event counting, etc. So if it is gate equal to 1, then it is the duty of the timer 0 and timer 1 to provide timer and control. Okay, timer and counter. Okay, so a gate is responsible for on and off a timer. Okay, this gate is responsible for on timer 1, other gate is responsible for on timer 0. Okay, then we have gate equal to 0, counting occurs independent of INT signal, that is interrupt signal. It will not look the interrupt signal. If gate equal to 1, it will depend on interrupt signal. Okay, so gate equal to 0 means this timer and counter is not using because the timing controlled by software only. The start and stop timers are controlled by TRX control bit, that is timer run control unit. Okay, timer run. Then set, okay, start the stop timer. So set TR means start the timer and clear TR means stop the timer. Okay, so gate equal to 1, then we are using the timer or counter hardware. Timer or counter is enabled only while the interrupt pin is high and TR control bit is set. So timer control is on only when there is an INT pin is high and also timer run is set. Okay. Then next one is, so we have discussed what is gate, what is C bar, T bar. Then we have M0 and M1. Okay, this is used to select the timer modes. So timer have different modes. That is timer 0 and timer 1 both have different modes. Okay, so uh, the timer 1 and timer 0 will be work in different modes. If timer 0 work in mode 0, then it may be timer 1 will work as mode 1. Okay, so these are independent. Then next, used to select the operational mode in the respective timer. So we have M1 and M0. So we have already studied there is 2 bit. Then we have 4 combinations, that is 00, 01, 10, 11. There are 4 modes, that is mode 0, mode 1, mode 2 and mode 3. So mode 0 means 13-bit timer. 13-bit timer means there is 13, start from 13 zeros and end at 13 1. That is 13-bit timer. Here we are using 13 1-bit. Okay, so the higher timer byte, the timer higher byte is 8-bit and lower byte have 5-bit. So a 13-bit timer mode, when it is used as mode 0, it's work as 13-bit timer mode. Only 13 bits are using. So the higher 8-bit and lower 5 bits are using. Okay. Also, counter overflow is indicated by the interrupt flag, that is TF. Okay. If timer 0 is overflow, then TF0 will be set. If timer 1 is overflow, then TF1 is set. Overflow means it will reaches 1111. Okay, then after overflow, the programmer want to reset it. Okay, so this is the case of 13-bit mode. Then the second one is mode 1. This is 16-bit mode. Okay, so in 16-bit mode, we have the higher byte as 8-bit and lower byte is 8-bit, and same the counter overflow indicated by the interrupt flag TF. Okay, then next is 8-bit auto reload, that is mode 2. So THX hold the value which is to be reloaded. When each time TLX overflows, TLX means TL0 and TL1 overflow loaded with the value THS is nothing but we have TH and if it for timer mode we have TH0 and TL0. So 8-bit is used, that is 8-bit auto reload. So in TL0 it is start with the 00. In TH0 it have 000. Okay, 8-bit. Okay. So after counting, then counting, the timer increases and it reaches overflow, that is 1111. After it reaches overflow, the TH0 is responsible to overload. So for a timer 0, no other programmer or no other external device is needed for reloading. If the TL0 is used for counting and TH0 is used for reloading if it is overflows. So when TL0 is overflowed, TH0 contain the value 000, and after overflow the TH0 will reload 000. Then it continue its process. Okay, so this is called a 8-bit auto reload. Okay, then the last mode is mode 3. It is called split timer mode. Okay, the split timer mode is nothing but for timer 0 establishes TL0 and TL0 as two separate counters. For timer 1, it will stop counting, which means that there is timer 0 and timer 1. Okay, timer 1 in these three mode, that is mode 0, mode 1 and mode 2, timer 0 and timer 1 works differently. That is, if timer mode works in mode 1, then timer 0 will be works in, if timer 0 is works in mode 0, then timer 1 will be works in mode 2. Or if timer 1 is work in mode 2, then timer 0 is work maybe work in mode 1. So these two are independent. But in case of split timer mode, these two are dependent, which means that timer 0 is responsible for counting. So the timer 0 is works in mode 1. Let timer 0 is works in mode 1. Then what is the duty of timer 1? The timer 1 duty is to control the TF, that is timer overflow, and TR, that is timer run control bit. So the timer 1 used to check the TF and TR of timer 0. So timer 1 is used to stop counting and start counting if overflow occurs. So all these are looked for is understand by timer 1. So timer 0 is used for counting. So if timer 0 is works in mode 0, mode 1 or mode 2, then timer 1 is not working anymore. The timer 1 is used to control the timer 0, that is for stop counting, for start counting, and that timer 1 responsibility is looking the TF and TR bits of timer 0. So this is called split timer mode. They are working together as a counter. Okay, so the first one is counting. It maybe works in vice versa. That is, if timer 1 works as counter, then timer 0 look after the TF flag and TR flag. Okay, so that's all about today's class, that is timers of 8051. Thank you.